Oh, here it goes. They changed the interface again, so I'm like, what the heck is going on? Okay, I think it's recording. Yeah, which is always a good thing to have on audio. I think I'm recording. All right, so welcome everyone to today's Map and Davis workshop. Today we're going to do the thing we've all been waiting for that we never get time to do with when we do intro to QGIS, which is actually do stuff with Rasters. So Lauren Mabe is here and she has written us a intro to QGIS with Rasters specifically, so we don't get caught up in just vector and never get to the Rasters part. Which is what usually happens. I forgot to introduce myself. I'm Michelle's bias. I think I'm the geospatial data specialist is my last what we decided to call me. I used to work here in Data Lab, but as of the first of the month, apparently officially work in scholarly resources in the library. That's not going to change map time though. We're still doing map time. I just now am in charge of map room as well as all the other things. So that being said, if you'd like to come hang out in the map room, Tuesdays from 1 to 3, the map room will be open, and I will be holding office hours down there. So come ask me spatial questions there, or just come look at maps. And it's kind of a map party. We've done it once and it was super fun already. I'm enjoying this. So what is map time? Map time is literally just time for maps. It is something that is an international concept. It started in San Francisco many years ago with people who just wanted to have time to make maps together. And it's sort of spread out throughout the world. There's map time all over the globe now. And ours is a little bit of an academic flavor because we're on an academic campus and supported by the library and data lab. But basically the whole point is just to get the geo people from campus into the same room, talking about maps and hanging out and learning stuff together. So super low key and super chill, just no pressure, learn what you learn. If you have questions, ask them here, come to me in office hours on Tuesdays, whatever. Yeah, so that's the plan with map time. We do have our map time is made by a group of people that we call Map Time Davis Council. Essentially, we are the folks who plan all of this and make this happen. And it's not something I do by myself. It takes an entire team to make this thing happen. So if you would like to join our team for the next academic school year, we have an application that is currently out and available. I think it closes. Yeah, okay, there you go. May 18th. I think it's like 8 or 9 weeks. So fill that out. Super. Don't stress about it. Just write what comes to mind. We're basically checking to see if people have some idea of what map time is and that they're good community members. So it's a low bar. But fill out the application. I just feel like you don't need to have like map research skills. Like I don't care if you, as long as you open the GIS program in the past, like that's the kind of like skill level. It's not like you need to have like dozens of years of research experience. Like you need to do this effectively. So like we really just we want people who want to do this and to help.
Make sure you would live in the general area.
Yeah,
I want to apply from like not in the US.
Yeah, we have someone apply from abroad, like on the literally the other side of the world, which doesn't make sense.
Like somebody said, it's a low bar.
Yeah, yeah, but like the whole point is community, so
Yeah.
That's what we're doing, and we really, aside from like what you see in terms of planning for this, we also need help with like our website, with our communication. So like if you are excited about doing like social media, we would really like to do that, but we just don't have the time with the current people. So like there's all kinds of stuff you can help with. You don't necessarily need to write workshops. You can if you want, but you can also help with other stuff. So there's a lot of jobs to do and there's a lot of ways to contribute on the team.
And running the workshops for grad students and undergrads is a good way to get like teaching experience without having to TA the whole class. You can be like, look, I can teach GIS. And not have to TA LBA or 50, which is a lot of work.
Yes, and you can help too, like you don't have to write workshops, you can help with like, when we have like a bunch of people, sometimes we need helpers and stuff like that, so lots of good help. I will talk forever, so I think I'm gonna stop there unless there are questions, and we'll jump into the workshop again.
I have a question and it's nothing about anything that was just said.
Right.
Okay, so I'm trying to install QGIS on Debian and it says, do I want to install the QGIS server? Do I want to install the server?
Okay.
But it's, I've got it installed. I just want to know if I want to install a server. No. Server? No. Just desktop.
Like, I don't think I
What is the server?
I I'm on Windows.
Put up a web server.
Oh, yeah, sure.
That
Alright, I can
they must do it, that was other.
Everyone like QGIS installed that wants it installed, it's not required. You can just watch it. Alright, cool, well then,
Cool, well, hello, you know me, don't know me, I am born in Maine, I'm a PhD student in geography. Hopefully in the last year, we'll see. Yeah, I've been working with Map Time, I've been doing some of the intro to QGIS workshops and kind of realized we skipped the rasters. So I'm doing it. That said, I don't really work with rasters in my own work, I just don't listen to people. So there might be some things in here that don't translate to larger projects. I'll try to point those out though. There are some things we're doing today just for demonstration purposes rather than this is good practice. I'll try to keep it moving. Cool. So for our workshop, yeah, this is a beginner workshop, focusing on rasters. The main things, if you want to follow along, you need to have QGIS on your computer. Other than that, I'm really trying to set this whole, workshop material, set the workshop up, so they're single, on their own, you can do them, follow along. This is kind of like part 3 in Map Time's like intro to QGIS workshop, so we do have 1 and 2. The first one's more of like, I need to make the maps right now, and I need to know how to change the colors of things and move things around. The second part is a little bit more about how to kind of do a little bit more analysis in QGIS. And so today, it's kind of more of that more analysis level stuff. We probably will skip the symbology part again, but we'll try to get to it. I'll try to get to it. So the main thing, load rasters, convert them, data types, polygons, things like that. We're gonna run some tools, some of the more fundamental raster tools. There's definitely ones beyond that. And this one we're actually gonna try to perform a actual multi-Critera analysis, which is a pretty useful form of analysis that's often very raster-based. So this one's, you'll be doing science today. And then part 5, which again we want to get to, is visualizing rasters, but I really try to write the workshop out to be step by step. So if we don't get to that today, work on it on your own, or come to a work session. Like on Fridays. Feel good? Sound good? Cool. Okay. The first thing I want to address is just like why QGIS. You know, QGIS is a GIS, a geographic information system. There's other GISs, Esri ArcPro or ArcGIS Pro is probably the other big one that you may have heard of. Why QGIS over something like Esri ArcGIS Pro is because honestly for me it's free. It's free and it works completely out of the box. My partner works a job where they have her use Esri ArcPro, and she needed to do a slope analysis, which is something we'll do today. And her organization doesn't pay for the extension that allows her to do the slope analysis. Whereas QGIS, you download it and you can do it. So I'm a big fan of that. Also, you know, let's say you are in a situation where you do, you know, work somewhere where they require you to use a different GIS. The fundamentals of GIS are the fundamentals of GIS. You might have to relearn which buttons to click, but if you know a workflow that you need to do, it will translate across any GIS. So I'm a big fan. I've been using QGIS for the last like couple years exclusively, and I really like it. So we're talking. I said rasters a lot. So I think we should cover what rasters are. So basically with spatial data, there's 2 main forms of spatial data. You have vector data and raster data. So vector data stores information as a set of points, lines, or polygons. So these are like discrete objects that have solid boundaries, right? State boundaries would be a polygon, a stream or a river might be a line, a tree could be a point, right? And so that is generally stored as vector data. You also have things in the world that you might want to map that are continuous, right? Elevation exists everywhere. Temperature exists everywhere. Air pressure, things like that. Those exist everywhere. We can't necessarily draw complete lines. And so that's where raster data comes in. So raster data is more like a picture where each piece of information, or each, it's composed of cells or pixels, but we call them cells. And each piece of information, each cell holds that thing. The elevation at this point is higher than the elevation at this point. And of course you can wing, but generally vector discrete, raster continuous, that's kind of what you want to stay in. And so it just stores the data and displays the data. That makes sense. And so, like something like elevation as a vector is kind of those classic like topographic maps where we kind of draw lines around specific times. And we really don't want to use this unless you have to. We will stay. But.
Yeah, it's that format is really common for land cover. So you'll have like raster land cover, and so you'll have big blocks of cells that are different numbers that correspond with like could be like crop types or like land use types and things like that, because it's easier to store. But that's where you see sort of a classic use case of raster for discrete things. But mostly I would say you generally don't want to do that unless you have a real good reason.
Yeah. We'll have to do it for data type purposes, but we'll get there. We'll get there. That is the thing. That's what when we say raster, we're talking about these two bottom lines. So today's sample project is going to be a multi-criteria analysis. So there's other, they call them other things, I think I have to break down. But generally, a multi-criteria analysis is where we're trying to find, I don't know, like the optimal location to host a data center or something, which means nowhere, but that's the problem. And so what a multi-criteria analysis does is it takes different spatial data layers and basically just stacks them. It assigns weights to each layer, it stacks them, and then it outputs one layer of bad areas and good areas. And medium layers and all in between. And so for this project, we're going to use our the data that we used in the other workshops, which is about San Francisco, seismic hazard zones and disaster and things. So in this workshop, we're going to pretend that we are the San Francisco Department of Emergency Management, which happens to be DEM, which is funny. So we're using DEMs, so type of raster anyways. And we're looking for the best place to put a relief center in the case of an earthquake. In this case, it's very simple. The relief centers have to be somewhere that is relatively flat, and it also has to be somewhere that is not seismic hazard zone. Because why would you relief center in a hazard zone? So our multi-criteria analysis only has 2 criteria. Realistically, you could have many more criteria. So let's get started with doing science here. The first thing we need to do is download the data. It is hidden in the word this. Sorry about that. Should have bolded that. You'll find this link to this box folder. And when you want to download the box folder, click this button over here to download the entire folder as a zipped folder. You don't really want to do these separately because that would just take a while. Okay, once you have those downloaded, at this point, this is where if you need me to slow down or repeat, definitely raise your hand and ask me to. So once you have your folder downloaded, I moved it somewhere. You want to put it into a folder that you can find it. That is very important when working with GIS, that you know where your data is stored. Don't let your computer do what it wants. You are in charge of the computer.
So when you say that, you mean have one parent directory that stores all of your GIS projects? Or
that's how I do it, but for my own personal research, like that has all the GIS data for my personal research is in my research folder. So I have a GIS projects folder for just kind of random projects unassociated with another project.
I think the key is that typically people who have less experience with their personal computers leave everything in a downloads folder and then they can't find it. So we find it's important to tell people to know where you put it so you can find it again, because you're gonna need to navigate to it. You're probably fine.
On desktop, I go through box drive, whatever you do, maybe desktop's also maybe bad practice, but for now, it can work. So you have your zip folder downloaded. You're gonna cut or copy it to you, I was cut. And paste it somewhere you can find it. So I have a GIS projects folder. You might have a research folder, some other folder that you're all like to work in. I would make a new project I called it Intro to Rasters QGIS. And then you can paste your zip folder into there. Oops, there we go. If you need to work out your downloads today, hey, I don't recommend it, but
As long as you can find it, that's.
fine. Well, once you have that copy, somewhere you know where to put it. You want to extract that, because the zip folder, it's all compressed, you can't get into it zipped up, we want to let the computer get into it. So on Windows, it's extract all, I think on Mac, it's something similar. And this is a weird thing about Windows, is it will put the folder within another folder, so if you're doing Windows, I recommend pulling this final folder out, so it kind of stays where you want it. If you don't do that, it's not a big deal, just, you're like going through 2 folders instead of 1. So again, we're telling it where we want it to extract. I'm doing it through Box and then my GIS projects folder, where I work on stuff.
Also plug, if you want more options when you're unzipping things, and you're on Windows, I'm not sure if this is on Mac or not, but 7-Zip is a really good program to add that gives you a lot more options for unzipping things. It also can unzip other zip compressed formats besides just zip files.
And then once I unzip things, I typically keep the zip folder. You could delete it if you wanted to. I like to keep the zip folder just so that it's like, this is what I downloaded. If I start messing with it, things go wrong, I still have the raw data. I will say, if you've done these workshops before, I actually added a new file for this workshop, so you will need to get the new data for this. All right, let's take a look at it once we have it unzipped. So the first thing you'll notice is we have lots and lots of files, even though I said we only have, or the workshop material said we only have seven data sets in here. There's lots and lots of files. This is because some files have friends. Vector data, shape files are composed of many files. They have friends. They need to stay together. That's why we have shoreline, shoreline BRJ, shoreline ship, shoreline SHX. All of these shorelines will need to stay together when you're messing around with your GIS data. That said, we then also have things like DEM-SF, DEM-30SF, which are just one file. So rasters hold things generally in one file, sometimes more, but whereas vectors, if you're using shape files, those will have friends. Make sure you keep your friends together. All right, everyone's got their data. We got data somewhere we can find it. Feeling good? Cool. Seriously, this is when you're like doing GIS, this is a lot of it. It's just downloading and putting data somewhere you can find it. So you've already learned a lot. All right, next thing we need to do is start QGIS. Woo! It's a pretty big program. It might take a little bit. If I was smart, I would have had it recorded.
It's extra slow when you're running Zoom at the same time. So
You have 3.4 installed. I have 4.01.
Oh,
Is that going to be an issue?
yes. Sorry. So the thing with so 4.0 works really well. The problem is that the plugins haven't been ported over. So the big change from version 3 dot whatever to 4 is they changed the Qt library, which is the library that does the graphics. And so a lot of the plugins haven't been ported over. So Mabe, are we using any plugins today?
I mean, we're using just the tools.
Okay, but you're not like installing plugins.
No
Okay,
plugins.
then you should be fine.
Okay.
Yeah.
Should probably put in the thing what version you do.
Yeah, I switched over to 4 right away because I was like, yay, new version, and then like none of the plugins I needed are available yet, including my own plugin because I haven't fixed it. So there's only a couple. So that's the big reason not to switch to 4, but as long as we're not using plugins, you're fine. Yeah.
That's all good.
Okay, yeah.
Straight out of the box, it's all good.
Okay.
All right, if you've used QGIS before, you'll see your folder or your previous projects. If you haven't, this section will be empty. But we're starting a new project, which is right here, project templates. You can also go through project if you wanted to. Cool. And this is what QGIS looks like. I have an extra toolbar installed. You probably won't see this one right here. That's an extra toolbar I have installed, but you should see the basic toolbars. Add data button and things like that. We also have our layers panel over on the left. When you start adding data, it'll show up in this layers panel. And I keep my QGIS pretty bare. You can also like have various other panels, but I think if this is your first time or second or whatever time opening it, it should look like sort of like this.
You might have the browser panel, which you can leave open if you want. It doesn't matter.
Panels also immediately. All right, everyone's open up. It might take a while, so I don't want to lose anyone. All right. If you did the next steps workshop, you could open that one if you wanted to, but we're gonna go through everything again, same might as well. Keep your blank project open. Cool. Everyone feel good? All right. So there's lots of ways to do things in GIS. So if you were to like go to Google how to do the things that you're learning, you might find other methods that work better for you. But I'm sticking with the methods that work best for me. So just a warning. All right, so the first thing we need to do is add some data. There is a data source manager. It's this button that looks like, I don't know, 3 little post-it notes with a plus. I believe you can also go to layer data source manager as well. And on Windows, it looks like you can even hit Control-L for a shortcut type person.
So a real quick housekeeping thing, I just realized the audio is coming through my computer and not your computer. So can you turn your mic on and I'll turn mine off and we'll see if we capture some decent audio for the rest of this. Sorry, I just was like, what is going on?
All right, there we go.
Let's see, hopefully it is fine, but
All right.
sorry about that.
Sorry, anyone watching on YouTube later. All right, so we have our data source manager. This is something that's different than ARC. If you guys ever used an ARC product, is that you actually need to tell it like what type of data you want to get. I guess you could go through the browser and just get whatever you wanted, but I actually like being more specific. So the first thing we're going to do is we're going to open up, I can't remember what one I went in order. I guess it doesn't super matter. Is we have 2 vector data sets that we'll need. I know we're working with rasters, but you'll need some vectors. So first thing we'll do is go to our little vector sign. Looks like a little V. And it also is labeled. And then we hit these little ... here. And that'll help us browse. And then we go get our data from wherever we stored it. So I have mine in my GIS projects. Intro to rasters. Intro to desktop. And it'll still show up all your files, but it's looking for vector data sets. And we need the seismic hazard zones because we want to make sure that we don't, that we don't use anything in a seismic hazard zone. And so in this file, you don't need to click on, remember I said vector datas have friends and you need to keep those friends together. You don't need to click on all of them. You just need to click on the shapefile in QGIS. So QGIS will know to look for the friends when you tell it open the SHP. I think technically you could click on any of them, but I always just make sure I click on the SHP. So we'll need our seismic hazard zones. Wait 1 second. And then we'll also need our shoreline, just to know, the shoreline of SF. So you hold Control, click on the SHP, and you can add them all together at once.
Shapefile that .shp and .shx.
I actually don't know what the SHX is. Alex does.
SHX is spatial index. It's an optimized index for finding things faster based on their location. SHP is the actual geometries of the objects.
Okay. So the SHP is the geometry.
Database format where different parts of the database are stored in separate files.
Okay. So yeah, SHP is the geometry, the shape. SHX is some index, some computer thing that's above my head. The PRJ is the projection. And the one that for me is open office spreadsheet, that's like the data associated with it. That's the attribute table. So that's why you got to keep them together because they're all one file. Cool. Okay, so we should have a shoreline and a seismic hazard zones. We can hit add and it'll add into your layers panel. If you missed one of them, it's no big deal. We can just go back into, oops, I clicked away. We can just go back into our data source manager, go to browser, and find the one we're missing. So these are the two that we need. The other thing is if you accidentally add them twice, just so you know, it will add them twice. So now you have two of the same layers. You can right click and remove layer for one of them. You only need one. Okay, hold on. I gotta move. Sorry, my little panel's in a weird spot. Now, I accidentally clicked and it went who knows where. So you can click on this button here. Come on, show me what it's called. Which will kind of zoom to our extent here. If you get in like a zoom, you're like, so you click this little magnifier, we want to zoom in, and now it's all being weird. Always just go back to the pan, and that'll kind of be like a more normal, like we can click and drag. And you can also zoom in by using your mouse wheel. Zooming in and out is another way to move around. Now, when we zoom to extent, there are some shorelines that associated with SF that are like these little islands out here. Normally you might want to like clip those out and all that, but we're just going to kind of ignore that. It's going to cause some weirdness later, but just know it's because there's some islands that are way out here in the ocean. The main thing we want is San Francisco here. Now, the other thing we notice is we can't see our hazard zones. That's because our shoreline is a polygon. I know it says line, but it is a polygon. And it's on top of our seismic hazard zones. So we can actually also, in our layers panel, kind of rearrange the layers and draw them differently. So if we throw our hazard zones on top of the shoreline in the layers panel, then they'll show up on top. Everyone got something kind of like this? Might be different colors. If your colors are ugly and hard to read, sometimes that happens where it's just like they're like too similar and you can't read them. You can just double click on the little box next to it, go to symbology, and then change your color to whatever color you want. So if you need to do that, you can. But my colors are actually really good. I like my colors, so I'm going to keep them. Yeah, there's lots of ways. The cartography in QGIS can get really, really specific, but that's how you can change the colors quickly if they show up kind of ugly. Okay, those are your vectors. Now we have two DEMs. We're only going to work with one, but I'm going to have us load two so we can kind of take a look at them. So again, data source manager. We'll go to the raster tab because we're looking for rasters now. we go to Browse, the three dots. And our DEMs are called DEM SF. I'm holding Control and DEM 30 SF. So you can add both of those at the same time. Hit Open. Leave everything default. Hit Add. And now we have, for me, we get this like transformation thing comes up. Has to do with projections. We'll talk about projections in a sec. We're going to just let the computer decide on this one and hit OK. And so these look pretty much the same. They showed up on top of each other here. So a DEM stands for Digital Elevation Model. If you ever need elevation data, you're looking for a DEM. There's other forms of elevation data, but generally DEM's a good place to start. And you'll notice when you open it up, it's like that doesn't look like what you think elevation looks like. Like it just doesn't look real. Like, I don't know. I had someone recently, I was like, yeah, you need a DEM. And she opened it up and she's like, this isn't right. They're like, no, this is right. This is what they look like. And so every cell in the DEM holds a piece of information. That piece of information is elevation. And so you can kind of see, here's the center of SF and all the black water, 0 elevation. This is what Marin County over here. So, and we'll figure out, we'll do some things later of how to make this look prettier. But for now, we're just going to leave it as is because it holds the information that we need.
Why do you want both?
We want both just for demonstration purposes. I'll show you. I'm moving on in a second.
My understanding is these are 2 image files that are layered on top of each other. They're not like our polygons where we can really see what's underneath.
Yeah. Yeah. And so, I mean, if I were to, they're basically the same. So if I move the 10-meter one on top, it doesn't super change. Or you can also turn it off by checking. And it doesn't super change because they're basically the same. And I'll tell you why, I think right now. Oh, wait. I'm glad I wrote this. Let's save our project. So the first time you save it, you want to make sure, again, you save it somewhere that you can find it. I'm going to save it in the same general folder that I'm working in. So Intro to Rasters QGIS. And then down here, you'll give it a file name. I'm going to call it Intro to Rasters in QGIS. One thing you'll note is I used underscores instead of spaces. Sometimes GIS software just does not like spaces, so don't use spaces in your file names. Don't use special characters either. You got numbers, you got letters, you got underscores. That's all you want to use. And that goes for file names and layer names, because a layer is a file. Cool. We got it saved as something. Numbers, spaces, or numbers, letters, underscores only. Cool. Oh, you can have dashes? Oh, I did not know that. I'm an underscore. I use underscores. It's a style. This is like a style thing. All right. So let's get, oh, cool. Okay. So let's get into why I had you download 2 DEMs. So with rasters are composed of pixels. They're called cells. And those cells have a real size. So typically it's going to be, maybe not typically, but often it is a 30 by 30 meter cell. And so that's like what, maybe half a soccer field? I guess soccer fields are not all the same size, but 30 by 30, half a soccer field, something like that. I looked it up at one point. We also have a 10-meter DEM, which is 10 meters by 10 meters squared. And so if we zoom in on DEM SF, that's our 10-meter, you'll see that it's pretty smooth. I'm just zooming into a random hilly area. But you'll see it kind of looks like terraced. It kind of looks like almost like it's got an old topographic map. You can see these lines. But you can't see the pixels unless you zoom super far in. Because the pixels are quite small. They're only 10 meters by 10 meters. This terraced effect is like sort of common with USGS DEMS. So you would think like smaller cells, it means it's more specific. But this is like a weird problem with the way that USGS DEMS were created, that sometimes they have this kind of terraced look. And so if we turn DEM SF off and take a look at DEM 30, you'll see that that terrace thing is missing, but you can see the pixels, right? Because the pixels or the cells, I need to stop saying pixels, the cells are larger. I don't know, it just feels weird.
Why is it an issue that it looks terraced as you?
Because it is terraced.
But so is that an issue?
Yes. For what she's gonna do now.
So what we're gonna do, it will be an issue. It's also, it's not necessarily terraced like that. And so it's something you're like, why is this an issue? Why isn't it? This is where like, it depends on what you're doing. Since we're doing a slope analysis, the terraces are gonna kind of mess up our issue. Or are gonna cause an issue. It's gonna kind of mess up the slope.
Was to like think about data quality and does the properties of the data we have match what we're trying to do? And with raster data, you definitely need to assess this, like, is your cell size the size that is what you need? Is it too big? Is it too small? And then also in this case, we have a data quality issue that wasn't an issue for the intro to QGIS workshop when we originally wrote it. But now the slope analysis is a problem because the data is terraced, but the real world is not. So there's a mismatch in what we're trying to do.
Yeah, so it's really just knowing, basically this is like knowing that the different cell sizes exists. Like if you're doing some sort of remote sensing thing, you're like trying to count the number of buildings or something like that. Like a 30 by 30 square like can have many buildings within that 30 by 30 square. So again, this is just kind of a resolution distinction here. 10 meter, no cells, but kind of causes a weird issue that will be a problem in this analysis. 30 meters, you can see the cells, but since our analysis is pretty big, that's actually okay. So I'm actually going to tell us, let's get rid of DEM SF. Let's right click, let's remove it. Because we're not going to use it. That was just for demonstration purposes. We're using our 30 meter DEM. Also, if you're doing raster stuff, sometimes it's also often important to make sure that your cell sizes all match. But there's ways to like rescale and stuff, but that's like outside of our point here. So yeah, that's just a demonstration of the difference of cell sizes, and it's up to you, the user, to learn which is important when. The next one we're going to do is also a bit of just a demonstration, because rasters can be quite large. And so sometimes doing running tools on them can take a while. One of those being the reproject. So we cover projections a little bit more in the next step workshop. There's also, it's from ArcGIS, there's also like a good link to kind of explain coordinate system map projections and transformations. But basically, a projection and a coordinate reference system is, we have a spherical Earth and a flat map. And so to make that spherical Earth into a flat map, we have to warp the Earth in some way, right? And so a projection is a different way, are different ways to warp and unwrap the Earth. And knowing what projections to use when is, again, beyond the scope of this workshop. But we are going to learn how to reproject, because it's often very important that your layers are all in the same projection. Because if you have one that warps the Earth this way and one that warps the Earth the other way, the data might not match correctly on the ground. There's also the coordinate reference system, the CRS, that's kind of a separate thing. That's the grid that's applied. So some grids are measured in meters, some are measured in degrees, like degrees of a circle. And so again, knowing which reference system your thing is in is important. So we're actually going to reproject our raster. Again, sometimes you don't want to do this, but we can do it here just to show you that it exists. So our raster is currently in a projection called WGS 84. That's pretty common. And the vertical unit of our DEM is in meters, right? So but the XY unit, you know, latitude and longitude is in degrees. And 1 degree is like 70 miles. So it's really hard to like do any sort of measurement there. So I'm going to have us reproject our raster into a projection that uses meters for the XY so that our XY and our Z match. So first thing we need to do, for some reason in QGIS, they call it warp. There's probably a reason for that. Okay. So the first thing we need to do is open the tool. Fortunately, if you're working with rasters, they're pretty much all your tools that you'll need are in the raster dropdown. It will be raster, projections, warp, reproject. So our input layer is going to be the layer we want to reproject, which is our DEM30SF. Then we need to find the, I guess the source CRS is optional, but whatever. We're gonna skip that. It'll know, the computer will read that, but we do need to tell it the target CRS, what we're trying to get to. So what you want to do is over here, click the select CRS button that looks like, I don't know, a little globe wearing a hat. So click on that, and then we will use a predefined CRS. We're not going to define our own. And then I have the ones up here, but the one we're looking for is called UTM NAD or UTM Zone 10. So you can go ahead and search for that here in the little search bar.
You got that PS code number?
Oh yeah, because there's a lot that are similar.
Yeah, if you can tell us the number, like there's the authority ID column.
Oh yeah.
What number is that? We can search for that. We'll get the right one.
I think the one I like, or the one I've used before is EPSG 366 or 6339. I guess you could also search that. Either way, NAD 83 UTM Zone 10. And again, I'm skipping over a lot here. This is a bit of a just do what I say kind of situation. Sorry.
You might have, if you haven't used this before, you might have to expand some of the sections on the warp window. Mine like condensed really small on the port reference system part, and I couldn't see it, so just a heads up, it might smash some things up for you and have to expand sections.
Everyone find 6339.
One cool thing, is you can kind of see it on the screen a little bit, where that red box is, that's showing you where, the coordinate reference system applies to geographically. So one thing I always forget is which UTM zone we're in here versus Southern California, which is zone 11. So this shows you that like, hey, this one actually applies to San Francisco. Error when I
Hmm.
It says not find Proj.d.
Hmm.
You're missing Proj. How did you install the QGIS? Yeah. I did that several weeks ago. Okay. You might just try uninstall and reinstall QGIS, because it sounds like it just didn't include Proj library, which is the library that has all of the protection definitions.
We lost one. We lost someone already. It always happens. It always happens. I know. I was considering not doing this, but I think it's important that people know projections exist just as like a core GIS thing.
Data is not actually projected, it's in angular units, so that makes like slope calculations like impossible.
Yeah, well, you can do the Z factor, but I'm like, this is such a core thing is knowing projections and CRSs and failing at being able to do it, having to redo it and all that. Again, welcome to the world of GIS.
angular units, so
Oh.
you need to reproject in order to get linear units.
Exactly, there, exactly. Okay, we lost Crease, but we're gonna move on without you if that's all right, because it might take you a while to. Maybe. We'll have to think of the Z scale. If you try it maybe one more time and just try doing a different UTM Zone 10 as well. All right. While Grease tries again, we're gonna explain. One thing that QGIS does that if you're used to ARC, it doesn't do or doesn't do by default is QGIS creates a temporary file. And you'll know it's temporary because it's got this little like bug looking guy. I actually really like this because the temporary files are nice because if you're doing like 3 or 4 things to get to the final file you need, you're not saving a bunch of stuff to your computer and having to do all that. So we do have a temporary reprojected file that we can actually just leave this temporary if we wanted to. But I'm actually going to go not what the directions say, and I'm going to say let's save this because once you reproject something, like we might need it again in its reprojected form. So we can right click on reprojected. Chris, you don't have to do this if you to get it to work. Right click, and then there usually is a make permanent, but apparently not. Then export. Whoops. Then save as. So that'll open the save raster layer as. And so you can just type in the file name here, but this is where I'm like, don't do that. Always tell the computer where to save things. You are in charge of the computer. So when you're saving things, always go to browse, the 3 buttons, and tell it where you want to save things. Your computer will eventually figure it out, and there are ways to set the computer where it always saves in the same place, but I always tell it where to go. And so I'm going to save this as DEM30SF UTM10.
Yeah, I see that. Yeah.
Right. So when we're saving some things, we want to give it a descriptive name that tells us what it is, but try to keep it short. So this is DEM30SF. It's Inform UTM10. So. And I'm saving it in my Intro to Rasters QGIS folder here. Okay. Okay. And that saved version shows up in our layers file. We can delete the reprojected temporary file because those are the same. So let's not get confused and work with the temporary. Let's delete those. Cool. So you've done a lot. Again, you have reprojected, which is again a fundamental GIS concept. You've also saved a temporary file into a place that you can find it, which is again going to be fundamental to working with GIS moving forward. That's all good. I'm actually going to skip this part, just because I don't think we quite need to do it. But you can do it, where you can clip mask, or you can clip, or it's called mask raster data. Our raster data is pretty small, so it's not really going to like bog down our computer, but rasters hold a lot of information, and so it sometimes is helpful to make them literally smaller. In our case, ours is pretty small, so we don't need to do that. So I'm actually going to skip this part just so we can get to the fun part. But I do want you to know that that is possible. You can clip rasters, and you can clip them to the area that you need. So you can clip it to the shoreline if you wanted to, or you can just clip it to the extent and make it a smaller rectangle. But we're going to skip this portion because we don't actually need to do it. So let's skip 4.3 and move on to the next step, which is the vector to raster conversion. This is another one that we actually will need to do, or raster to vector conversions. This is a bit for demonstration purposes and because we will need to do it eventually, is you can convert rasters to vectors. But one thing you do need to keep in mind is that rasters are composed of square pixels. I should use my thing. And so the vector that you create won't have this like beautiful, nice, diagonal line. The vector you create will have that square outline. And the degree of that square outline, depends on the size of your raster. So if you've got a 30 by 30, you'll see the vector is a lot more stair-stepped than something smaller, which might look a little smoother when you zoom out. Oh, I named this incorrectly. It's another edit I need to do. Well, we have to do another projection. So basically, in our multi-criteria analysis, all of our layers need to be raster layers. So our seismic hazard zones are vector layers. So we're going to convert that vector into a raster. So the first thing we need to do is reproject. Again, all of our projections need to be the same when we're doing analysis. So again, fundamental GIS component. So to reproject a vector, we're reprojecting the seismic hazard zones here. Actually, let's move them up. We will go to vector, data management tools, reproject layer. Our input layer is seismic hazard zones, the one that we're trying to use. And our target CIRS, since we've already done this, hopefully shows up in the dropdown. And it should be, again, UTM zone 10. If it doesn't, you can always click on the globe with a hat and go find it again. Cool. So input layer, seismic hazards. Target CRS is going to be UTM zone 10, which should be available in your dropdown since you've already done this. We can run that, and our little temporary reprojected file shows up. And so it's not a huge change. You can't really see the difference, but the computer knows the difference. And we're actually going to keep this one temporary because all we're trying to do is get it into a raster. So we don't actually need to save this. You can, but let's not, just to save some time here. Everyone has a reprojected seismic hazard zones. Feeling good? I didn't lose anyone other than Crease, who's already been lost. All right. So now we need to do our vector to raster conversion here. So this is actually in the raster menu this time. So raster, conversion, rasterize, vector to raster, because we have a vector data type for the polygons and we need them to be a raster data type so that we can do our raster-based analysis. Once we click that, we choose our input layer is going to be reprojected, that temporary layer. Do I choose a burn-in value? I don't think I do. Oh, fixed value. Okay, so I'm jumping ahead a little bit. It's hard to doing things. We're not going to use a field. We're going to burn in a value. So basically this means is like what value is assigned to the cells. And so we could assign a different value to the cells based on the data in seismic hazard zones. But for us, we want all of our seismic hazard zones to have a value of 3. So that's our fixed value to burn into our new rasters. Sorry, I don't know my settings. Yeah.
So if you want to use for a burning value, you take from the table and make all of like the polygons with value 5, 5, 4, 4.
Yep. Yeah, if you had like, let's say in your seismic hazard zones, you had like degrees of hazard and that was a column in your attribute table, you could make that part of your raster. And that's actually, I think, a bonus task I wrote down. The other thing we need to tell it is what's our raster size. We want it to match the DEM. We're using a 30 by 30 meter. So let's use our geographic units or georeferenced units because we are using UTM. Our width/horizontal resolution is 30 because we're using 30 by 30 meters. We're in a CRS that is 30 or that is measuring in meters. Just want to make sure I got my things. Vertical resolution, I think I also said 30. And then what else did I say we need to do? And then the other thing it asks us to do is set the extent. How wide across the earth do we make a raster for? So I always just have it do this button here, set to current map canvas extent. So it's going to fill, our map canvas with some sort of raster cell. Right. So input layer reprojected, fixed value to burn 3. If it's a high seismic hazard zone, it will be 3. If it's not a seismic hazard zone, it will be 0. We're using georeferenced units, 30 by 30 resolution, and we clicked this little set to current canvas extent button. So it knows how far to make this raster. Feeling good? We'll hit run. Here we go. And if I turn everything but that rasterized off, you'll see our seismic hazard zones are now a raster. And you can kind of tell they're a raster because they've got that zigzaggy, jagged cell thing. And so all of our seismic hazard zones are a raster of the value 3. And you can also tell because when I turn the vector back on, it covers up the raster here. So cool. Now we definitely do, I think. Oh, shoot. We got one more thing we got to do. So we noticed, as we could tell, we have just these cells. The raster is like shaped like the seismic hazard zones, but I kind of want it to be, a full square, right? It's either a 3 or a 0. So we need to fill in those cells, these empty areas. And so to do that, we will use the fill no cells tool. And so that's in the processing menu, toolbox, that's in the raster toolbox. So we're now getting into toolboxes here. So processing, toolbox, that'll open our toolbox here. And then this is in raster tools, fill no data cells. You can also just search fill no data cells up here and it'll come up. So our input raster is going to be that temporary rasterized layer. Again, it's only a raster in the seismic hazard zone data. Band number is for if you're using like remote sensing data, just leave it as 1. And let's do our fill value as 1. I found when I was making this and when I had it say 0, it was all weird. So fill value is 1.
Is that because the 0 is different?
I honestly don't know why it didn't like zeros because it should be fine with 0. Like a raster should be allowed to have values of 0. But for some reason it just like was being weird. So we're just gonna have it fill 1 and not deal with it. Sometimes that's just how GIS works. You're like, I don't know what's going on, but when I have it as a value 1, it doesn't mess up. If we hit run, it'll give us a temporary vector, but we actually can just tell it to save without doing the temporary vector. If we do that, again, make sure you hit browse and tell it where you want to save. So you would click here on this output raster area. You'll click the 3 dots, save to file. And mine keeps going to a weird spot. And I can't remember what I saved this as. I want to try to follow the instructions. So we're going to just call this seismic hazard zones raster. Simple, right? It's descriptive. That's what it is. It's a raster version of seismic hazard zones.
I tried to do 0 and it seemed fine.
I don't know. It was being weird. So I was just like, we're just going to make it 1 is our lowest value and it's fine. Yeah.
And so let's save it as a tip, but in the vector, it's a shape.
Yeah. So this is kind of just file type stuff. TIFF is going to be a very common raster file type. The shapefile is a common shapefile type. There's also like GeoJSON is one, KML if you're using Google's whole thing.
Yeah, that's what format, data format. But this is a TIFF, just like an image TIFF, but there's extra header information in it that makes it GeoTIFF.
So if you forgot to save it when you saved it, and you got the temporary layer, you can always right click on your temporary layer, export, save as. So, and I'm actually going to get rid of my temporary layers because I don't like to keep them unless I know I need them. But if I know I need them, then I would have just saved them. So if that makes sense. So you should have something similar to this, where you have a raster where our lowest value here is 1 and our highest value is 3. There's nothing in between. You could do something in between if you wanted to. And so 3 is our seismic hazard zones. 1 is not a seismic hazard zone. And it's got this big kind of rectangle here. So we now have a seismic hazard zone raster. We reprojected the vector layer to match our raster. We then rasterized our vector layer. And then we filled in the no data cells so that we made sure we had one solid piece of information. So that's kind of a lot of data management for rasters. Like we had to do like 3 steps to get here. And that's just how it is sometimes. Like and that's kind of why I like the temporary layers. I don't know if there's any Esri people here, but I'm a big fan of the temporary layers. But that's a lot of data management. You guys just did like a lot of work here converting to raster. All right, are we ready to run some tools? Woo. All right, first thing we got to do is calculate the slope, because we got to remember our goal here. Our multi-criteria analysis, we need things that are on a low slope and things that are not in a seismic hazard zone. So we kind of did the second part already. We got ready for our seismic hazard zones. So now we got to calculate our slope. So we're moving back to the DEM here. I'm going to turn off the seismic hazard zones layer by unchecking it, just because we don't need it. And I'm going to turn on, if you haven't already, the DEM. So again, this is our elevation. And to calculate our slope, it's in raster analysis slope. Then once we do that, we have our input layer is going to be DEM30 SF UTM. Band is, we only have 1 band, so just leave that as 1. And so this is why we needed to convert to UTM, is because now our horizontal units are in meters and our vertical units are in meters. So our ratio of vertical units to horizontal is 1 because they're the same. If you were doing something where your vertical unit was meters and your horizontal unit was miles, this box here is where you would put that like conversion factor in there so that it knows the ratio. I'm going to keep it as a degree slope, but you can express it as a percent, and you can do some other things, but we're going to leave it all default, and we're ready to go. So this one's a pretty simple tool. We just tell it what layer, we tell it our ratio is 1, and we run it. And then I'm going to put that slope above the DEM so you can see it. And it looks a little weird, I'm not going to lie. The slope tool is a little bit better in larger areas. We're in a relatively small area with also a lot of weird vertical. But now our raster is again still black and white, but the white areas are areas of a high slope. The black areas are areas of low or zero slope, and various shades of gray in between. And it looks weird. This is just because of cell values and things like that. There's ways to fix this, but for our analysis, we're going to say this is good enough. Does everyone have a slope vector or slope? And let's go ahead and save this one. I made just to make sure. So we're going to right click on our temporary slope layer, export, save as. Click on our little browser so we tell it where to go. And it's finally starting to get where I want it. And we're just going to call this SF slope because that's what it is. It is the slope of SF. And for the most part, you can just kind of leave things as is. If you wanted to zoom in on the slope raster or something, that's where you could do like mess with this extent. But for the most part, we're just keeping everything the same as the current layer. So add it to map. It'll give us a second one. I'm going to delete the temporary because I don't need it because I saved it. Cool. Oh yeah, we're killing it on time. We're definitely not going to get to cartography. I'm so sorry. All right. So slope is like it's one of many, many, many tools you can run. That's kind of my example tool. Reclassify is another like fundamental raster thing. Reclassifying, I mean, there's lots of reasons you would do it. Basically, what reclassifying means is we are changing the values of the cells. So right now our cells range, I want to say from 0 to 49 or something like that. 0 to 49, that's the slope angle, right? Which again feels a little high. That might be kind of wrong, but it's fine for now. So what we want to do is we just want to reclassify that into high, medium, low. Because I don't really care exactly what the slope is, but I do care that it's high, medium, or low. Yeah, there we go. That's why it's 4. So I was like 49 seems like a lot. So we're just going to give those high, medium, low values. And we're actually going to give those numeric values. And that's kind of what something you'll do in your multi-criteria analysis is you give everything a value. And it's really up to the researcher to decide what that value is. But we're going to call high. Oops, I found another error in my workshop. Sorry. We're going to call areas of high slope, we're going to give those a value of 1 because those are not desirable. They have a low score. Areas of low slope, we're going to give a value of 3 because those are very desirable. We're going to give them a high score. I wrote this down wrong. Ignore this particular section. Bump everything up a value from this particular section. So to open it's another tool that we're going to run. It's the reclassify by table tool. It's also, this one's going to be hidden in the processing toolbox. So I'll show you. It's processing toolbox. This is something you can save to your side if you want to, but I don't know, I always close it. And we can go and find it, but we know the name of the tool we need, so let's just search for it. So reclassify by table. It's in the raster analysis tools. Once we click on that, we tell it what raster we're reclassifying, which is our slope raster. And we have this reclassification table area. So then we click on our three dots. That'll open up a new tool where we actually make our table. So we're looking, we need 3 classifications. So let's add 3 rows using the add row button. And this is where we specify what values we're changing. So our minimum value and our maximum value. So we'll say anything, any raster cell between this value and this value, we're going to give it a new value. So our minimum value is 0. I actually like to give it a little bit of extra buffer. So I'm going to say our minimum value is -1. And I can't remember exactly what I said everything would be. To 6. Okay. So anything from -1 to 6 on our slope is going to be given a value. Did I write that down right? That seems wrong. I don't know. We're going to go with what I said. 6 to 1, or -1 to 6, we're going to give that a value of 1. So any raster cell between those two values, they're going to be changed to 1. And then I think I have 6 to maybe 15. Sorry. 6 to 15 is getting 2. Or nope, 6 to 15 getting 2. And then everything 15 to the top of our thing is 49. So we're going to say 15 to 50, just to give it a little buffer, just in case. We're going to call that 3. No. The higher the value, the worse it is in our particular analysis. So there's some editing I'll have to do to this because I
Cause I feel like I thought you said that it was.
Yep.
But okay.
I said it backwards. I said it backwards. High value is bad. That's why we gave our seismic hazard zones a value of 3.
So ranking 1 is good.
Yes, 1 is good. 3 is bad. I realize I said that wrong earlier. Sorry, people on video. Yeah, I confused myself there for a little bit. 3 is bad, and I have that written down in the materials if you're following along the materials. 3 is bad. So this is what we're telling it to do. Anything low slope gets a 1, it's good. Medium slope 2, eh. High slope 3, bad. Then we can, so once we have our reclassification table, are we feeling good on that? We got everything filled in? I don't want to miss anyone. Okay. Then we got our table in. So we can skip the advanced parameters. I'm not worried about it. Do we want to save it? I think we will want to save it. Let's find out. Just to double check. Yeah. Oh, it says save temporary. So instead of making a temporary layer, let's just go ahead and save it here. Let's skip a step. Our reclassified raster. We're going to click the 3 buttons, save to file, go through our file paths, find where we want it. And I think I just called it slope reclass. Cool. Ready? Here we go. Let's run it. Nice. So now we have a little bit of gray in there. I'll turn all my other ones off. They're underneath, but this is kind of what slope reclass will look like. Again, those areas of like lots of slope, especially in Marin, wow. You know, they're a 3, they're bad. But these areas of low slope, which would include the ocean, which we'll have to cut out later, because we definitely don't want it in the ocean. Those are 1, those are good. So we did reclassifying. Nice. This is also useful if you're using like a land type. What's that called? Land cover. Thank you. Land use land cover. If you're using like a land cover raster, a lot of times it'll have like urban, semi-urban. It'll have like lots of classifications that are like kind of similar. And for your analysis, all you need is like urban, suburban, rural. You know, that's somewhere where you might reclassify things to kind of fit what you're trying to analyze or what you're trying to symbolize as well. Cool. We'll clip after the fact. So in my, if you're following along on the sheet, I had clipped earlier, but we skipped it today, so it's looking a little different than the sheet. But we only have 3 colors because there's only 3 classifications. All right, the final thing, this is the big thing, this is the multi-criteria analysis, is using the raster calculator. So it facilitates map algebra, which is calculations on the basis of the raster pixels. If you're doing multi-criteria analysis, again, you need to remember, you know, high values are bad, low values are good. And if you ever hear someone's doing like spatial modeling or something like that, they're often doing just very advanced raster calculations. Our raster calculation is going to be pretty simple. It's going to just, we're just going to add our 2 rasters together to make a score. I don't want to lose. If you're like close to getting it figured out, I don't want to lose you. Okay, we're gonna wait.
Instead of having, you know, classification, it's still 1 to 49.
Huh.
So that should be all.
I don't know. Give it a second shot. Did you, on your final one, did you do it up to 50? That's why I like giving it a little buffer.
Never.
Yeah, in your reclass table, you give it up to 50. Yeah, go up to 50 so it makes sure that it captures that final amount.
Sure, it says row 3 is 15 to 40 to 15 to 50.
Yes, I guess when I was doing this, the slope came up differently. Yeah, so when I was making this worksheet, it calculated the slope up to 38. So on the image, the reclass table is 40. But today, for some reason, when we're calculating it, it's calculating slope up to 49. And so you just want to make sure that that maximum value captures that.
Okay. Yeah, so I think what happened, because we didn't range, it was like freaking out. Yeah.
Like there's no way to
We learned something. Yeah, I was gonna point out, so. Yeah.
because line hates the raster.
Yes, maybe. It's possible that I did the slope calculation differently. I could have done it by degrees instead of and I realized that in the worksheet the slope calculated up to 38. So it's possible that I did degrees versus
You're just playing it safe because the theoretical maximum of slope, you know what that is, and so you could, if you really want to make sure that that category always has everything, just use the theoretical maximum of the column.
oh yeah, that's true.
You put it on 100.
Yeah, it's like it can't be over 100 slope. Like that's true. So anyways, as long as, I guess the point here is, as long as you capture the lower bound and the higher bound of the vector of the raster you're reclassifying, it will capture it. Cool. So we have something like this. It might look a little different. As long as you got 3 colors, black, white, and gray, I think we're ready for the raster calculator. And ours is going to be pretty simple. We're just going to add our 2 rasters together because we have 2 things we need to consider: slope and seismic hazard zones. So to get to our raster calculator, I already forgot how to get to it. Oh, it's just in the raster menu. You can also always just like, if you know what tool you need, you can always just search for it in the processing toolbox. I'm a big fan of going through the drop downs. I don't know why, I just like it, but raster calculator is so important. It's literally not even in a submenu. Like this is what people do when they're doing spatial analysis. So raster calculator. And we have, well, it'll tell us up here, it tells us our raster bands. It has all these operators, plus and if, all these things. And then we have our expression builder down here. And then over here on the right is where it we tell it what our result layer should look like. So ours is pretty simple. Like I said, we're just adding the two rasters together. So we have slope reclass, high, medium, low. So let's double click that. And you'll notice it comes up in quotes. That's just the way the computer knows how to look for layers. And when it comes to rasters, it also has this like @1. And so this is if you're using remote sensing where there might be multi-band rasters where you have like the visual light spectrum and the infrared spectrum and I don't know, ultraviolet spectrum, and those spectrums will come in on a different band. This is where you can specify which band you want. Our rasters don't have that. They only have one band, but that's what the @1 means. So we have slope reclass and then plus. You could type that. I like to click it. Seismic hazard zones raster. So pretty simple raster calculator, but you can make some really complicated stuff in here using the and the if and all that if you wanted. One thing that's nice is it says expression valid. So if you got a valid expression, it'll tell you. Question.
But it is in my layer, it's like present in the layer, and it's checked. I thought it did. Cause I caught up, but maybe okay. Continue and I will.
Is it a temporary layer? I might want it to be saved. Maybe.
Oh, yeah, it might not like temporary. It actually, I know it doesn't like temporary layers.
You can save it.
This one?
Oh, your temporary layers are showing up?
It has version 4, so.
Oh, there we go.
Features.
Maybe.
Yeah. And again, welcome to GIS world where you're like, why is this not doing what I think it should do? And it's all, yeah, it's a weird, and then it's like some weird thing where one person's on a Mac, one person's on it. It's so, yeah. So,
Oh, yeah. You can continue with.
so this is another one that I do know. The raster calculator, when I was working on this, didn't like being a temporary layer. You had to save the raster calculator layer. Is this true for every version of QGIS and every computer in the world? I don't know, probably not. But for my computer, it did not like temporary layers. So we are going to save our layer right now. So in our result layer, output layer, again, always browse, always tell your computer what to do. You're in charge of the computer. Oh,
It says.
that's a good point. Let's do that because that is what I said to do in the thing, didn't I? Yeah, let's actually make the sizing hazard zones more important. Thank you for catching that. This is what happens when I don't when I just kind of go by myself. So in the instructions here, I have it set to actually we want to make the seismic hazard zones twice as important as the slope. And so we can just edit our expression right here. So we have slope reclass plus 2 times seismic hazard zones. And I'm going to put that 2 times seismic hazard zones in parentheses again, just so that I control the computer and the computer does not control me, right? Parentheses, PEMDAS, all that. And so again, when you're doing multi-criteria analysis, this is another way to like assign weights to individual layers. What we also could have done if we wanted to, when we were doing our seismic hazard zones rasterizing, instead of burning in 3, we could have burned in 6. But I actually like doing it this way a little better. I think it's better to control. So this is where we're saying seismic hazard zones are twice as important as slope reclass in this analysis. And so we have slope reclass plus, in parentheses, 2 times seismic hazard zones. So our seismic hazard zones are 3 right now. What the 2 times does is it'll essentially kind of converts that to 6 before it does the calculation. And again, I don't know why my computer doesn't like on the fly rasters with raster calculators. So we're going to save our output layer. We're going to browse, put it where it belongs, all that good stuff. And what did I call it just to keep keep everything kind of together. Hazard score, because that's what we're doing. We're calling it a hazard score. That's what all of these things that we assigned are. That's what the 3s and the 6s and the 1s, it's the hazard score. It'll be a geotiff, because the TIFF is the raster format we're using. Spatial extent is going to use the selected layer extent, so it'll be the same as slope reclass. Resolution, output CRS, same as what we're already doing. So then we're ready to go. So feeling good? Slope reclass plus 2 times seismic hazards saved into a geotiff called hazard score. Let's do it. Woo! There we go. And so now we have this raster where the highest value is 9. So highest hazard score, 9. Don't want to go there. Lowest hazard score is 3, because remember we did kind of 1 as our minimum every time. And we multiplied one of those ones by 2 and then added. So the minimum's 3. And that's where we'd want to put our thing. So that's, I mean, that's the multi-criteria analysis there. We did it here. Woo! So we know, here, I'll turn everything off just so we can kind of take a look. So this raster here is showing us our hazard score. Oh, Treasure Island, they can't have a thing. Bummer. And so now we've kind of selected our areas where it's the best places to put our disaster relief areas. And we definitely know where we do not want a disaster relief area. So that's a multi-criteria analysis. Nice. You guys just did science.
Why would you just say don't put it in the hazard zone?
Yes.
And so this is just showing the extreme of hazard.
Yeah, well, so with the multi-criteria analysis it's kind of both things are the problem, right? Because if you're on, I mean, I'm sure you've been to San Francisco where it's, I don't know, I don't want to be like trying to help people after disaster and like it's on a slope. And so by doing this, we added both together. Now, in this case, the hazard zones are showing up very distinctly and very clearly. But there's also like other areas, like, you probably wouldn't want to put it in here either. And that's not a hazard zone either, but it's just too high of a slope. It's just going to be like a bad area. And so in a real multi-criteria analysis, you would also consider things like, I don't know, distance to water resources and transportation networks. And, you would include a lot more. And so since we doubled the effect, right, we multiplied the hazard zones by 2. That's why they're showing up so clearly in this raster. I think if you run the raster calculator without doubling them, they actually like don't show up at all.
I'm sorry, I was confused. I think I see it.
Yeah.
Black is no slope, no hazard.
No slope, no hazard.
Black in this case is where we want to put things if it's not.
Yeah. Yeah. And so this is where we would go back. We'd probably want to clip. You know what? Let's do it. We got time. Let's clip it. We don't want to put it in water either, right? And we have our shoreline there. We have our shoreline vector, right? And so we only want to put it in somewhere in the shoreline. So let's go ahead and clip this hazard score thing so that we don't accidentally put this in the ocean, because that would be really bad. So that's going to be in our raster extraction, clip raster by mask layer. So our input layer that we're clipping is going to be hazard score. Our mask layer, which is just kind of the raster version for clip layer that we're clipping it to, is the shoreline, because we only want things in the shoreline. The ocean's considered a 0 because it's not a hazard zone, but like clearly we don't want to put a relief center there. The CRSs and stuff, the computer will kind of do that for you, but I do think it's usually important to specify the target CRS because you control the computer. And since we've been working in UTM zone 10, let's go ahead and do that. I realize we didn't reproject the shoreline. Again, this is where the computer is, it will operate on its own. But let's make sure that we tell the output CRS what we want it to be, which is UTM zone 10, what we're working in. The target extent. I think we can just leave it. Let's leave everything else default. Let's see what happens. This is where temporary layers are very handy. Let's leave everything default and see what happens. We're going off script here. All right. So then clipped mask shows up when we hit run. Let's turn everything else off. Hey, there we go. Now we have our clipped raster. Okay, so these are the areas you'd want to put your relief center. Or areas you would not. Up here where it's really hilly, you don't want to put it at the top of the hill. Nobody will get to it. We can go ahead and save this if we want. We're going a little off script here, so I'm going to just kind of make something up. We're going to save this relief center areas. Something like that. You could also call this like hazard score clipped. Might be probably a more descriptive way to call it, but you also don't have to save it right now because we're kind of going off script here. Cool.
You're changing the colors of your
Yes.
spectra.
Oh yeah, we're gonna do that. We got to it. We got to it. Okay, so we're gonna skip part 6 here if you're following along. This is called post classification tools. There's like a whole range of these tools. The smooth raster is helpful. I'm just gonna explain what that is. If you zoom in really close to our clipped raster, you'll see that there's just some of these little teeny tiny areas that are, you know, like one spot that's bad. And you got to remember, this is 30 meters by 30 meters. And so if our relief center needs to be larger than 30 meters by 30 meters, it's sometimes helpful to just remove those kind of single individual cells. We're going to skip that section for now, but that's kind of what the smooth does. It just kind of removes those areas that you're like, it's too small to put a hazard zone anyways. So let's just kind of get rid of that area and smooth the raster out.
Would you get a sense of everything in that area 9 or 3?
So the way the smooth raster goes, the smooth sieve raster tool works, is it kind of just interpolates what's around it. So this particular kind of cell, which is probably a 4, it would say, okay, the cells surrounding it are 3s. Let's call this a 3. So this cell, this is probably 4 cells. Oh yeah, good call.
But in that case, you would bias the interpretation of the plot if there's just one 30-meter patch that's in screen.
Yeah.
Lowers everything else. It lowers that by with everything in the neighboring and so on.
Yeah.
Yeah.
So,
Yeah, that's what the tool is trying to do.
But then bias the interpretation of the viewer.
So there's 2 different things you're doing here, like you can do your analysis on the regular raster, but for visual purposes, you might reclassify it or like smooth it so that it looks visually better for the photographic product. So when we're doing GIS, we have sort of 2 components. There's like the science of calculation component, and then there's the communication component. So the smoothing might be useful for the communication, but you're right, if you're gonna smooth it, you wanna know what that impact has on the data before changing data. So.
And these types of considerations of like, well, I'm smoothing and changing the data, and whoa, it might change, like we might put a hazard zone or put a relief center there, and we actually shouldn't. Those are the types of things that, like, as the scientist, that you have to consider. And as the scientist and the analyst, like, is that something that I do need to consider? Is it something I don't need to consider? That's up to you. And I think that to me is what distinguishes someone who can run GIS from someone who can do an analysis, is like being able to ask those questions and solve those problems. And so it sounds like you can do the analysis, and right now you're learning to run the GIS. So, but yeah, it does technically the smooth sieve does change the data. And there's various ways you can also control how it changes the data and stuff like that. But that is a tool that exists, so I wanted to show that it's here. You can also convert rasters to polygons if you want that in vector format. I don't recommend doing that because again, you'll have like weird little teeny tiny vectors. But you could filter them using the smooth sieve and then convert them and whatever. So that does exist. Be careful if you have a large raster or a complicated raster from doing that. Finally, let's go ahead and change our map. Let's go ahead and symbolize our map just so that we can, make it a little prettier before we leave. Because we have this band. Okay, we're using Relief Center. I'm going to put that up top. Right, this kind of gray band, 0 to 3 to 1. Let's go ahead and change that so it's like a little more obvious, right? Like let's use like stoplight colors. Red means stop, green means go. So we can double click on that. That'll open up the properties. Oh, I think I might go through the symbology tab there's multiple ways to do everything. Oh, I'm using the layer styling panel in the instructions, but we're going to do it the quick way by just going through the symbology tab. So you will double click on your layer you want to change. You'll go to the symbology tab here, which kind of looks like a paintbrush. I think that's what it's supposed to be. And right now we're symbolizing it as a single band gray, right? So it's single band gray, high, low, black to white. But let's go ahead and change that to paletted/unique values. Again, when you're using rasters, be a little careful with this. There's only 9 unique values. No, there's even less. There's 6 unique values. So we can use the unique values here. If you have lots of values, like the actual slope dem, you would want to use a different thing. Pseudo color, thank you. I've been talking too long, I'm losing it. But we're going to use unique values because we know that we only have 6 values here. We'll use it. This is basically like using a classified symbology for vectors. So then we hit classify. It'll bring up all your values. Again, this is why you need to be careful using unique values with rasters. And so we could, if we wanted, just let it symbolize each, type, each section as it is. Here, I'll show you what that would look like. Very colorful. This is just using random colors. That's very hard to see. So I'm going to change some of these colors. I'm going to say 3 is our lowest hazard score. That's our best area. We can double click on the little color patch. And QGIS has lots of ways to choose the colors. I like this one sometimes if I'm being just this color swatches and then just the standard colors. And I'll choose this kind of dark green. So then, okay, apply, okay. Oops, sorry, I guess I didn't need to hit okay that much. And then let's see, 9 is like definitely don't go there. Let's make those black. Let's like don't go to black. I'm kind of making it up at this point. We'll call 4. 4 is an acceptable area. It's got a pretty low hazard score. We'll make it light green. Let's also make 8 black. 8 is too high of a hazard score. We don't want to put it there. Let's make that black too. And let's make 5 and 7. I guess there's no 6 somehow. It's just somehow calculated no 6. Let's make those orange. That feels like you could go there if you wanted, but there's probably better areas. There we go. So now we have like some green areas. Actually, there's quite a lot of space that you could put a place. And there's actually, with the hazard zones, that 7 score is showing up as orange. So since we know that these areas are the hazard scores, let's actually make 7 black as well. This is where cartography is a little bit of trial and error, what looks good, what doesn't. Kind of up to you. And then while we're here in the symbology, you can also change the label. So 3, we can call like lowest score. I don't know, making stuff up. We'll call this just low score. Let's call it hazard instead of score, so we know what the score is. Sorry. Call this 5, we'll call it a medium hazard. And we'll call 7, 8, and 9 do not locate. And so the fact that some of our hazard zones are coming up as like score 7, 8, 9 means that when we did our raster calculator, if we're like absolutely do not locate one here, we could have given it a higher weight when we did our raster calculator. So we made it a raster weight of 2, like twice as much, but we could have called it like 100, and all of the hazard zone areas would come up as 100, and we would know definitely that's a high zone score. So that's a little bit another one where it's like, I'm kind of showing you how to operate the GIS, but as the analyst, as the scientist, knowing how to weight things and how to interpret the results of things is kind of what makes you the analyst. So yeah. Oh, nice. In our since we called 7, 8, and 9 all the same label, it looks like it automatically updated our legend to not have 3 of those. So yeah. So that's mostly what I had. Some of the other stuff in here, there's another thing in here, how to symbolize continuous rasters. So the DEM itself, I just copied this from the part 1 of Intro to QGIS. And so that can kind of help you turn your DEM into something a little more legible as a elevation raster. The other thing I added in this section is adding a hillshade. So a hillshade is going to make it even look more like a hill. By adding this hillshade here. And that's just another tool that you can run. And then I don't know, I tried to make this map that kind of puts them all together with the hillshade and the vectors and all that. I don't know how well it worked, but. Oh, and then I have a bonus task if you really want to keep working and keep doing this. So we only did 2 criteria, but your bonus task could be to include other criteria that might be important to this, locating a disaster relief zone. So some of the things I think is maybe like transportation infrastructure. So you would go find some transportation infrastructure data, convert that to some sort of distance raster, something like that. Same with like water, sanitation, land use, right? If, these might be low elevation, but if there's buildings on them, then that really wouldn't work in an earthquake. Or medical facilities, right? You can do some sort of buffer distance analysis. So that's your bonus task. Because I think a lot of doing GIS is just practicing and trying different things and seeing what happens. So that's today. Did we have a question that I just kind of kept going? I was blabbering over. I don't think so. Okay. But yeah, that's rasters. We did a lot. Let's see, what did we do? First off, I mean, we loaded the rasters and reprojected them, which is a lot of what GIS is just getting data and loading it. Like that's like the biggest step to get over for a lot of times. Reprojecting, because reprojecting and projections in CRS is a fundamental aspect of GIS. We did some raster tools. We ran slope. There's other things you can run, especially with a DEM, you can do aspect. So it'll tell you like if the slope is facing north, south, east, or west, things like that. So that's another one you could run with the DEM. So we ran a tool. We did some reclassifying, another fundamental raster thing that you can do. We did some raster calculator, that's spatial modeling. We did some spatial modeling, essentially. We clipped a raster because, as we know, we did some analysis, right? Like we can't put it in the ocean, so let's clip, right? And then we did a little bit of resymbolizing in a simple way. So did a lot today. And like I said, doing GIS is a lot of practice, and And just sometimes like things weirdly don't work and don't do what you expected them to do, and so you just got to try again. You know, often it's just like a weird little parameter that you missed. So that's really all I got. I don't know. Any questions? Any like comments, concerns? Yeah, thank you.